Okay, here's another interesting problem we have. Given that 4 raised to the n plus 6 raised to the n is equal to 9 raised to the n, what is n equal to? So what are the solutions of n such that it satisfies this given equation here? I'm going to actually do the easier method. There's actually several ways to solve this problem, but I feel that solving with this method that I'm going to demonstrate for you guys is it works better, in my personal opinion. So I'm going to rewrite 4 to the n plus 6 to the n equals 9 to the n. And what I'm going to do is I'm actually going to divide 4 to the n raised to the n to both sides of the equation. So that would be written as equal to 1 plus 6, and then they share the same exponent, so we can actually rewrite this as 6 divided by 4 raised to the n equal to 9 divided by 4 raised to the n. Okay, and we can actually simplify this a little further too. So this is 1 plus 3 divided by 2 to the n, and then note that 9 divided by 4 is also the same thing as 3 square divided by 2 square. So what that means that they share the same exponents, both the numerator and denominator, so we can actually move it outside of the parentheses. So we can actually rewrite this as 3 divided by 2 raised to the 2n. So now what I'm going to do now is we're actually going to do a substitution. So I'm going to let t equals 3 divided by 2 raised to the n. And so when we substitute that, we have 1 plus t equals t squared. So, and I'm going to subtract 1 and subtract t to both sides. So we actually get a quadratic formula. Minus t minus 1 equals 0. And you can't factor this out, so we're actually going to have to take the long way and use our quadratic formula. So we write this as t equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Then we just substitute our numbers. Negative t, so this will just be 1 plus or minus the square root of b squared is negative 1 squared, so that's just 1, and then minus 4 times 1, then times negative 1, so that'll just be plus 4, and then divided by 2 times 1, so it's just 2. And in other words, t is equal to 1 plus or minus the square root of 5 divided by 2. Completely unnecessary, but this is interesting. The number 1 plus the square root of 5 divided by 2 is actually a special number known as the golden ratio. It's not really important for solving this. I just thought it was interesting to point out. So anyway, now we actually have two solutions for the quadratic formula t, or quadratic equation. T is equal to 1 plus the square root of 5 divided by 2 and 1 minus the square root of 5 divided by 2. But we're being asked to solve for n. What is n equal to such that the given equation here? So we're actually going to substitute back t for equals 3 divided by 2 raised to the n. Let me get rid of this. So that means we have 3 divided by 2 raised to the n equal to 1 plus or minus the square root of 5 divided by 2. And now the last thing we have to do is just solve for n. And the simplest thing we could do in this case is we actually have to take the logarithm of both sides of the equation. So using our rules, we have the exponent n, so that can just go out to the front of the log function. So it's just n multiplied by the log of 3 divided by 2, and then take the log of the other side as well, the log of 1 plus or minus the square root of 5 divided by 2, and then we can just divide the log of 3 over 2 from both sides to get our solution for n, which we have two solutions. So I'm going to write the two solutions separate. So n is equal to log of 1 plus the square root of 5 divided by 2, n divided by the log of 3 over 2, and n is equal to the log of 1 minus the square root of 5 divided by 2 divided by the log of 3 over 2. Like so. And there we have it.